Hello class, today we're going to talk about section 8.3, which is quadratic equations in the form x squared plus bx plus c is equal to 0. By the end of today's lesson, you'll be able to factor trinomials with the leading coefficient of 1. So, a quadratic equation is an expression where the variable has a degree of 2. So that's this exponent with the first x. Notice right in this definition it says ax squared plus bx plus c. Today we are dealing with the case where a is equal to 1. So that leading coefficient is equal to 1. For future reference, that leading coefficient can't equal 0. Otherwise x squared goes away and we no longer have a degree 2 polynomial. So we're dealing today with where this a value is equal to 1. Quick review here from last chapter. Remember, when you had two binomials, you had a couple of options here. You could use FOIL, so x times x, which gives us x squared. And then outside is 5 times x, which gives us 5x. Inside, 7 times x gives us 7x. And last gives us 7 times 5, which is 35. Combining that together, I get x squared plus 12x plus 35. Your other option was to use the box and set it up in a 2 by 2 format and say x and 5 and x and 7, which gives you x squared, 5x, 7x, and 35 after multiplying, which again, combining your like terms, gets you back up to the x squared plus 12x plus 35. This was our answer last chapter, and it's going to be the start of our problem this chapter. So our goal is to get back to these factors. So it's going to give us the answer expression, and we're getting back to those binomial factors. So how we are going to do this, the key piece of information right now is this last number, this c value. So your first step here is going to be identify c and find all of the multiplication factors of c. So for example, in this one, 1 times 8 is 8. And 2 times 4 is 8. So those are all of the pairs that multiply to 8. After you find the pairs, then we're going to pay attention to this middle term, which is 6x. We need to look at which pair of multiplication can add up to 6. So in this case, we have 2 and 4. 2 plus 4 is 6. Then to finish solving the problem, we take a very simple step and break it into 2 pairs of parentheses. X is going to be the first term because that comes from x times x is equal to x squared. Then I'm going to add 2 and add 4. This is because 4 times x gives us 4x, 2 times x is 2x for a total of 6x, and 2 times 4 is 8. So we undid that FOIL process or that box method to figure out what our two factors are. You could have switched them around and said x plus 4 and x plus 2. It doesn't matter the order as long as both parts are present. Go ahead and try this one on your own. Factors of 21 are 1 and 21 and 3 and 7. In this case, we needed to get to a negative 22. So we've got negative 1 and negative 21. So we subtract 21 and subtract 1. It also, again, could be written in the format m minus 1, m minus 21. Both of those answers are correct. Another example here, now we have a negative for that c value. So we've got negative 18. We're going to worry about the negative sign in a minute. The first thing you want to do is still just figure out the factors of 18. So 1 and 18, 2 and 9, and 3 and 6. We haven't worried about the negative yet because we don't know exactly where it's going to go. Now we look at that middle term, which gives us a negative 7. So 2 of those numbers have to add up to negative 7, which actually means we're going to start involving the negatives. So if I look at the pair 2 and 9, that can get me to 7 by doing 9 minus 2. But I want to get to a negative 7, so I'm going to make it a negative 9 and a positive 2. Again, we just break that down into our two binomials, so x plus 2 and x minus 9. You could switch it and say x minus 9 x plus 2. Again, order doesn't matter as long as both answers are present. Go ahead and try this one on your own. This time we are looking for a positive 13, so the factors that work are 16 and negative 3. Again, we had that negative 48, so I needed one positive and one negative factor. X minus 3, x plus 16, or vice versa, x plus 16, x minus 3. Couple tips here. If that C value is positive, so that last number is positive, both of the factors have the same sign. Either both factors are going to be positive or both are going to be negative. Example 1 was both positive, and example 2 was both of them negative. If they have a negative C value, we've got the factors having opposite signs. So one of them's positive, one of them negative. This was example 3 and 4. So those just show you a quick shortcut to help you figure out if it is positive or negative for those factors. Then we have problems where we actually need to solve. Our goal is still to be able to find those binomial pairs, and in order to do this, we need the equation to be set equal to 0. So I'm going to subtract 27 from both sides, and I get x squared plus 6x minus 27 is equal to 0. If the equation does not equal 0, you cannot solve it. So you have to make sure that one side of your equation is completely equal to 0. Then I'm going to go through and find my factors of 27, which are 1 and 27, and 3 and 9. Looking at the sign on the last number, I've got a negative 27, so that means I'm going to need one positive factor and one negative factor. In this case, I want to get to a positive 6, so I'm going to have positive 9 and negative 3. So I've got x minus 3 and x plus 9, and that's still equal to 0. The solve portion of this means that each of the factors need to get set equal to 0. So x minus 3 is equal to 0, and x plus 9 is equal to 0. Solving the first one by adding 3 and adding 3, I get an answer of x is equal to 3. So that's the first answer. And then the second one, I'm going to subtract 9 and subtract 9. So I get an answer of x is equal to negative 9. So when I'm solving, I'm going to end up with 2 values for x. Go ahead and try this one on your own. Factors of 70 are 1 and 70, 2 and 35, 5 and 14, and 7 and 10. Again, we have the negative sign on the 70, so one positive factor, one negative. In this case, it's negative 10 plus 7. So I've got x minus 10, x plus 7. Solving both of those pieces, my answers are x is equal to 10 and x is equal to negative 7. Couple of word problem applications. So we are looking for the area of this banner to find the value of w. You'll remember that the area formula for any rectangle is area is equal to base times height. So in this case, it tells us that our area is 72 inches. So I've got 72 is equal to the base, which is w, times the height. If we look on this right side, I've got w plus 2, and then I've got another 4 inches. So total, I've got w plus 6, the 2 inches from the bottom portion, and then the 4 inches from the top portion of the banner. Now, in order to continue to solve this problem, we're going to need to get rid of those parentheses using the distributive property. So I've got 72 is equal to w times w, which is w squared, and 6 times w, which is 6w. As I said before, in order to solve, we need to have one side of the equation equal to 0. So I'm going to take away the 72 and get 0 is equal to w squared plus 6w minus 72. Off to the side, we're going to list our factors. So 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. I'm looking for a pair that can be subtracted to positive 6 because I have that negative sign, so I need one positive and one negative. The pair that works is 6 and 12, so we got 6 minus 12. So our factors are going to be w minus 6 and w plus 12. Setting both of those equal to 0, I end up with w minus 6 is equal to 0, giving me an answer of 6, and w plus 12 is equal to 0, giving me an answer of negative 12. Now, because it's a word problem, I have to think about this logically. We've got 6 inches for the length, and we've got negative 12 inches for the length. It does not make sense to have a negative length value, so I've got my final answer of w is equal to 6 inches. Go ahead and try this one on your own. Same type of thought process here. We've got x times x minus 8. Distributing and then subtracting that 48 gives us this blue equation to solve. Factors of 48, going through and finding them, the pair that works is 4 and negative 12. Setting those both equal to 0, you get an answer of x is equal to 12 and x is equal to negative 4. The one that makes sense is the positive one because we can't have negative length values. If you have questions about this or anything else from the lesson, please let me know when you get to class.